Hello everyone and welcome back. We're in our second lesson now of our Patterns in Algebra unit. So our second lesson is called Rules for Sequences. And in this lesson we will extend the number sequences using a verbal rule and identify simple verbal rules. So the verbal rule just tells us what we're going to do with the numbers in the sequence without telling what each of the individual terms are. So can you describe the sequence of these numbers listed at the top without listing the individual terms? The pattern rule for this sequence could be start at 10 and add 3 to get to the next term, or we could say start at 10 and add 3 each time. So this gives us the rule without telling us what each individual term is in the sequence. So a complete pattern rule will tell us two things. First, it'll tell us what is added or subtracted each time, and then it will tell us where the sequence starts. So here's an example. If we start at 20 and add 5 each time, we know the first number will be 20, and we can write that gap up here of plus 5, and our next number will be 25. 20 plus 5 is 25. We could write the gap again. We don't have to since we have it written down in the rule, but we can. But 25 plus 5 will be 30. We know that the next one will be 35, and so on. And we can add the 3 dots or ellipses to show that it continues on. Here's another example. So what would the pattern rule be for this sequence? The numbers are 2, 6, 10, 14. As a hint, what was added or subtracted each time? So let's look at 2, 6, 10, 14 is an increasing sequence, so we know we must have added something. Well, first we know that we started at 2, so let's write that down. Start at 2, and we know it's going up, so we're likely adding. We haven't done any multiplication or division sequences yet, so we can assume that we will add. Now let's look at the difference between 2 and 6. There's 4 there. If we're going up by 4, then we add 4 each time. See if that holds true. From 6 to 10, we add 4. From 10 to 14, we would add 4. So there's our pattern rule. Start at 2 and add 4 each time. Here's some exercises for us to practice with. If we write the first 6 terms of the sequence, 1a tells us to start at 14. So we'll write down 14 as our first term and add 3 each time. Well, 14 plus 3 will give us 17. 3 more is 20. 3 more is 23, plus 3 more, 26, and 3 more will give us 29. There's our first 6 terms of the sequence. And we could add the ellipses on the end, but it just asked us to write the first 6 terms. So we don't need to show that it continues on. We can assume that it does. For B, start at 35. So our first term will be 35. And subtract 2 each time. So 35 minus 2 will be 33, minus 2 will be 31, minus 2 will be 29, minus 2 will be 27, and minus 2 will be 25. And again, there's our first 6 terms of that sequence. In C, we start at 12. There's our first term. And we're adding 7 each time. So 12 plus 7 will be 19. 19 plus 7 is 26. 26 plus 7 will be 35. Nope, 33, sorry. My mistake. 33 plus 7 will be 40. 40 plus 7 will be 47. So there we go. There's the first 6 numbers or terms in that sequence. So this question, number 2 here, asks us to write a rule for a sequence and then use that rule to write the first 5 terms of the sequence. So our rule could be start at 27, subtract 3 each time. Okay, so if we start at 27, so that will be our first term. 27 subtract 3 is 24. Subtract 3 again will be 21. Subtract 3 again will be 18. And subtract 3 again will be 15. And there's our first 5 terms in the sequence. Now, if you would like a bonus question, I'm going to let you do this one. I'm not going to help you with it, but here's a bonus to find the 4th term of the sequence. Because sometimes you don't need to find all of the terms. Sometimes you just need to find some of them. So if you start at 5 and add 3, what will the 4th term be? Start at 40, subtract 7. You can pause the video and just see what you would come up with. So if you've done those 2 bonus challenge questions, then your answers there will be 14 for the first one and 19 for the second. So these exercises ask us to find the gap, or the number that was added or subtracted to make the sequence. So if our first sequence is 69, 64, 59, 54, we know we're subtracting. What would the gap be? What number would go up in here to go from 69 to 64? It's a decreasing sequence, we're subtracting, and the answer is 5. For B, now we've got 35, 39, 43, 47. Obviously it's an increasing sequence, so we're adding. So the gap between 35 and 39 is 4. From 39 to 43 is 4 again. From 43 to 47 is 4. So we're adding 4 each time. In C, now we have to figure out, are we adding or subtracting? 43, 54, 65, 76. It's an increasing sequence, so we must be adding. So we can use the addition sign, or we can write the word add. And we're adding 11 each time. The last one here, 119, 116, 113, 110. It's a decreasing sequence, so we must be subtracting on this one. And we know that the gap between 119 and 116 is 3. That holds true for all the other ones, so we're subtracting 3 each time. Here's a problem-solving situation. We've got 2 students, Clara and Grace, who are doing their homework together. They're given a sequence and need to identify the pattern rule. So the sequence is 43, 36, 28, 21, 13. And Clara says the sequence is made by subtracting 7, because 43 minus 36 equals 7. But Grace says the sequence is made by subtracting 8, because 36 minus 28 equals 8. Are their answers correct? Well, let's work this out. If we take 43 and subtract 36, what is our answer? We know we have to borrow here. 13 minus 6 is going to be 7. 3 minus 3 is 0. So our gap up here is minus 7. What about 36 to 28? 36 minus 28, what will we end up with? 2 there, 1 there. 16 minus 8 is 8. 2 minus 2 is 0. So we are subtracting 8 here. Interesting. What about 28 minus 21? 8 minus 1 will be 7, and 2 minus 2 is 0. So the gap here is minus 7. 21 minus 13. Let's try that one. 21 minus 13. Again, we're going to have to borrow. 11 minus 3 is 8. 1 minus 1 is nothing. So here we're subtracting 8. So this one is interesting because we don't have a consistent gap between the numbers. It goes minus 7, minus 8, minus 7, minus 8. This is still a pattern and still a sequence, but it's different from what we've been working with so far because the sequence changes slightly. So who is correct? They're both correct, but they're also both wrong because the sequence is made by first subtracting 7, then subtracting 8, then 7, then 8, and so on. So this one is a little bit of a different rule and a little bit different to figure out. Here's a little bit different of a question. This one tells us that one of the sequences was not made using a rule. Find that sequence and state the rules for the other two sequences. Now you might be able to see this right off the bat. I don't know. But let's look at the first one. We've got 25, 20, 15, and 10. Well, we can easily see that that one, we are starting at 25. Start at 25, and I'm going to use the subtract sign and subtract 5 each time. All right, let's look at B. We've got 6, 8, 10, 11. Well, from 6 to 8, there's a gap of 2. 8 to 10 is a gap of 2. But 10 to 11 is only a gap of 1. So it doesn't seem like that would really work. That might be the one that was not using a rule. Let's look at C and see what we come up with. 9, 12, 15, 18. Oh, if you know how to count by threes, you know that that's what we're doing here, right? So here we start. Okay, my pen isn't going to work. I think I'm just going to have to tell you. We would start at 9 and increase by 3 or add 3 each time. All right, so then it becomes obvious that yes, B is the one that is not made using a rule. Because it looks like it starts out as a rule, but we have to look at all the terms that they give us to show that it's not actually a rule. That brings us to the end of our lesson. So you can go to your workbook, your practice book, and work on pages 4 to 5. Again, if you have any questions, please don't hesitate to contact me through Schoology or by phone if that works better for you, and I will be able to help you with that. See you next time.